The diagram below represents a bicycle chain which passes over two circular wheels with centers A and B. The smaller circle has length radius 4 cm and the larger circle has radius 11 cm. The distance between A and B is 25 cm. The sections CD and FK are tangents to the circles and LB is drawn parallel to CD. Find the total length of the chain correct to 2 decimal places. Now, AC is the radius from the center to the point of contact of the tangent at C. So this chain is tangential, and we know that we have a right angle here. Because LB is drawn parallel to CD, we know that this angle here is also 90 degrees. This line is parallel to this line. So these are also known as corresponding angles. We have a similar situation over here actually. CD is tangential to this circle here, so we have a right angle here because this line is a radius to the point of contact. This line here is parallel to this line here, as I said already, which means that this shape here is a parallelogram. As a matter of fact, it's a rectangle. It's a parallelogram that is a rectangle, so the opposite sides are equal. So if this is 4, then this distance here is also 4. Now the total distance of C to A is 11, so 11 minus 4 is 7. So the distance AL is 7. So I can look at the right angle triangle ALB and I can find this line here, that's LB, by using Pythagoras. So I'll call it X. So the hypotenuse of triangle LAB is 25. So the square of the hypotenuse is the sum of the squares of the other two sides, 7 squared plus X squared. Solving this, I get X equals 24 centimeters. If LB is 24 centimeters, then the distance of C to D is also 24 centimeters. By symmetry, the distance of F to K is 24 centimeters as well, because I could have repeated all this calculation for the lower half of this diagram. We want the length of the chain, so we want this major arc of the circle CF. So it's called a major arc because it's the largest arc of the circle joining point C to point F. The minor arc would be this arc here. To get the major arc, we need to get the proportion of the circumference that's taken up by CF, arc CF. To get that proportion, we need to get this angle here. In order to get this angle here, we have to get this angle in here. But this angle in here is part of our right angled triangle. Calling this angle X, we can see that we can use one of our ratios for a right angled triangle. I could use cos, sine, or tan. I'll use cos. We see that the cos of angle X is the side adjacent to angle X, which is this side here, which is 7, divided by the hypotenuse of the triangle LAB, which is 25 centimeters. Now we want a final answer to 2 decimal places, so it's probably a good idea to write this down to more than 2 decimal places and round at the very end. Maybe write this down to 4 decimal places. To 4 decimal places, this is 73.7398. So this is the inverse cos of 7 over 25. Now to find this angle here, which I'm calling Y, what we do is we multiply x by 2 to get all of this angle here, and we take that result from 360 degrees, which is the angle in a full circle, and I get 212.5204 degrees. Now to get the length of arc CF, by arc I mean the major arc, what I do is I put this angle Y, which is 212.5204, over 360. So we get the proportion or fraction of Y out of a full revolution, and we multiply that by the circumference of this circle. The circumference of a circle is 2 pi times the radius. 2 pi times the radius, and the radius of the circle is 11. To 2 decimal places, I get an answer 40.80 or 40.8 centimeters. The next thing we need to look at is the minor arc dk. This distance here from D to K, it's the minor arc in this circle. The distance from D to K around this way is shorter than the distance of D to K around the other way. This distance of D to K around this way is known as the major arc. Actually, if I extend the line AB on through here, through B, and look at this angle in here, this angle here is actually the same as this angle here, which is X. These two angles are the same. Actually, I'm sorry. This angle up here, of course, is 90 degrees. But what we have is this line here parallel to this line here. Why are they parallel? Because this is 90 degrees and this is 90 degrees. So both of these lines make an angle of 90 degrees with this line, so they're parallel lines. So this line is parallel to this line, which means that we have a pair of corresponding angles. We have this line here cutting through these two parallel lines and forming these two what are known as corresponding angles. Corresponding angles are equal. So if this angle is X, this angle over here is X. And similarly underneath here, this angle here is also X. So what we want is this angle here. And this angle here will correspond to this arc dk. This angle in here is 2 times X. That's 2 times 73.7398, which is 147.4796. So what we do is we get this angle here as a fraction of 360 degrees. We just divide it by 360 degrees and we multiply it by 2 pi r. 2 pi r is the circumference or length of a full circle. The radius of this circle is 4. I've written this down to 3 decimal places. I get an answer of 10.296 centimeters. So to get the length of the chain, we take this arc here, 40.8, add it onto twice the length of the two straight parts. That's 2 times 24, and then we add on the length of this arc here, which is 10.296. So I get 99.096. Now to 2 decimal places, we add 1 onto this 9. We get 99.10 centimeters, or 99.1 centimeters.